Hello everyone. So in today's lecture we are going to discuss about Siemens PLC. So Siemens is basically a German based company. Okay, so around 28% of the industrial automation sector all over the world is captured by Siemens itself. It has wide variety of products, but for industrial sectors, mainly PLC systems, DCS systems, and HMI and drive systems are the major products of Siemens company, right? So here one terminology is step 7. Step 7 is basically a standard package used for configuring and programming schematic programmable logic controllers. So basically step 7 is one of the packages which provides us software as well as the hardware systems. Okay, so Siemens provides software as well as hardware system for programming or controlling in the field devices. Okay, so what is basically step 7? We'll be looking here. What is step? Step is basically Siemens technical education program. This was basically an education program which was introduced by Siemens to teach people how to configure PLCs, how to program their PLCs, and how to design HMIs, and all those things were taught in the Siemens technical education program. Okay, here if you observe, there are 4 series of PLCs available. Earlier there was S7 200 series also. In the Siemens 200 PLC is almost obsoleted now. Okay, so here majorly 4 series of PLCs are available. So S7, basically S means what? Again it is step 7 only, and S7 300, S7 400, S7 1200, and S7 1500 are the major series of PLCs. Under this there are numerous CPUs available. See, if you observe, there are number of CPUs available. Okay, so each and every CPU is in advance to other. Okay, so if you observe this 312, 313 and all this, as we increase in the order, here the 314 will obviously have more features as compared to S7 CPU 312 or 313. Now if you talk about the networks, okay, so here the networks are basically, there are 4 types of networks supported by Siemens PLC. So here first is PPI network. PPI is basically point to point interface. Okay, so point to point means obviously it will have only 2 nodes. So 2 nodes means what? One will be for PLC and another if we want to connect a computer system so that we can program our PLC. So obviously 2 nodes are used for this network, so only 2 PLCs or one computer and another PLC can be connected in this network. So what is the length of the network here? 2 to 3 meters, and data transmission speed here is 9.6 kbps to 19.2 kbps is the maximum speed. So speed is also very low. Now if you talk about multi-point interface, multi-point interface basically has 32 nodes. 32 nodes means what? Around 32 devices can be interconnected, and all the 32 devices can share data between themselves. And here the speed is 9.6 kbps to 187.5 kbps, and the distance here is 15 to 16 meters. Okay, so up to 15 to 16 meters this network can be established and efficient data transfer can take place. Okay, so now Profibus is basically another network, and this is basically process filled bus. Okay, so this is a bus in which multiple devices can be connected, and here we are having 126 nodes. So that means 126 devices can be connected and they can share data between themselves. Okay, and here the speed again is 9.6 kbps to 12 mbps. That means now see, if we are increasing in the order, here we are increasing in the order, the speed is also increasing, and the distance here is 21,730 meters. That means around 22 kilometers, right? So this much large network, or we can say up to a long distance also we can share the data in this network system. Similarly, Profinet is basically an Ethernet type of network, which is basically process filled network. It has around 1024 nodes. That means these many devices can be interconnected in this network, and the speed is also the speed of internet here, that is 10 to 100 mbps. The maximum speed is 100 mbps, and the distance is worldwide. Obviously it is connected to the internet, that means we can access or control the devices through anywhere in the world. Okay, so here are the some full forms available. So PPI is point to point interface, multi-point interface, and process filled bus, that is Profibus. Profibus is basically process filled bus, and they are again divided into two categories. So Profibus DP and Profibus PA. So Profibus DP is basically decentralized peripheral network, and Profibus PA is basically process automation bus. Profinet, that is process filled network. So already all these things we have discussed here. Now here if you observe, we are having some network. So if you observe here, these are the green lines. Okay, so these are the green lines basically showing the Profinet network. And if you observe here, these are the pink lines. These are basically what we can say, these are the Profibus network. Generally green color cable is available for Profinet network. See, if you observe here also, this is Ethernet network. So Ethernet network will only be using Profinet. Okay, so Profinet is basically the green color cable is available here. This is Profinet. And now we'll be discussing about Profibus DP and what is Profibus PA. We know that there are large number of instruments available inside the field, right? So see what we are doing, a large number of cables are coming inside the control room. So this is what basically increasing the cost of the cables, right? So suppose if we bring all these IO modules to the field itself, that means earlier these were connected near to the CPU. This is our CPU, and these are the IO modules. So these IO modules are actually connected to the near to the CPU, so they are basically local to this CPU at the moment, right? Now suppose if you bring this IO modules from this CPU, or we can say from the control room to the field itself, if you remove it from here and bring it to the field, then this will be remote to this CPU. Okay, they are away from this CPU, that means these are remote to the CPU. These IO modules are now been removed from here and are now placed inside the field, and now this will be remote to this CPU. So see, if you observe here, these are the remote IOs which are now present inside the field. Okay, so basically if you bring these IO modules inside the field itself, then the distance between the instruments and the IO modules will decrease. That means IO modules are now in the field and instruments are also in the field. So that means the distance between the IO modules and the instruments has been decreased. So the cost of cable has also been decreased, and the complexity of connection has also been decreased. Okay, so now we'll be requiring one single cable which will be sending this signal from IO module to the CPU. Okay, so the remote CPU, or we can say the CPU which is connected in the control room, that will be requiring only one single cable, and the IO modules, all the signals from the different instruments will be transferred from the field to the control room via single cable. This is what we call as decentralized periphery. Okay, so basically what we are doing is we are decentralizing the IO modules from the control room. Basically we were earlier, what we were doing, we were centralizing the network. That means each and every IO signal from the field has to be transferred to the control room. So all these signals were going to the single point, right? Now we'll be discussing about Profibus PA, right? So Profibus PA is basically process automation bus. It requires AFD. What is the meaning of AFD here is active field distributors. This distributors, see here, if you observe, these are connected to the Profibus PA. That means a process automation bus is here and these are connected in series. See, AFD here, again there is an AFD here, again there is AFD here. So we are basically having this AFD in the network, and we can connect instruments to this active field distributor so that the signal from this instruments will be transferred to this AFD, and this AFD will transfer it to the network, and then it will go to the CPU directly. Okay, so this is what we call as Profibus PA. So thank you.